बच्चों अभी हम 11th फिजिक्स का टॉपिक देखने जा रहे हैं, चैप्टर यूनिट्स एंड मेजरमेंट। यूनिट्स एंड मेजरमेंट। Firstly, we will talk about physical quantities. Physical quantities. What are physical quantities? So the definition of physical quantity is that those quantities which can be measured, जिस क्वांटिटी को भी हम मेजर कर सके, नाप सके, those quantities which can be measured, those quantities which can be measured are called physical quantities. Are called physical quantities. Those quantities which can be measured, which we can measure, are called physical quantities. As for example, suppose we have to measure the length of this blackboard. So it may be either 5 meter, 6 meter, 3 meter. So since we can measure the length of this blackboard, and this blackboard is measured in meter, and in meter what can be measured? Length can be measured. We are measuring the length. So length is the physical quantity. Length means distance. Length means distance. So distance is the physical quantity because distance can be measured. We can measure mass, 2 kg, 3 kg, 5 kg, 10 kg. We can measure mass. So mass is the physical quantity. Time can be measured, 10 seconds, 1 hour, 2 hours. Time can be measured. So time is a physical quantity. Area can be measured. Volume can be measured. Speed can be measured. So those quantities which can be measured are called physical quantities. There are so many physical quantities which can be measured. Now we will talk about fundamental physical quantities. Fundamental physical quantities. Today we will talk about three fundamental physical quantities: length, mass, and time. Length, mass, and time. They are fundamental physical quantities. The question arises, why length, mass, and time are fundamental physical quantities? So these are fundamental physical quantities because all other physical quantities can be expressed only in terms of length, mass and time. The question is, why these are fundamental physical quantities? So they are fundamental physical quantities because all other physical quantities, can be expressed in terms of length, mass and time. Since all other physical quantities can be expressed only in terms of length, mass and time, that's why these three quantities, physical quantities, are called fundamental physical quantities. As for example, suppose you have to measure speed or velocity. So how can we express speed or velocity in terms of fundamental physical quantities? We know speed. The formula for speed is distance upon time. Formula for speed is distance upon time. Distance means length, or time means distance, length, and this is time. So these two are fundamental physical quantities. Now, so speed can be expressed in terms of fundamental physical quantities. Similarly, acceleration. Acceleration is defined as rate of change of velocity, and the formula for acceleration is change in velocity upon change in time. Velocity upon time. And velocity equals to displacement upon time. Displacement upon time. And this is again time. So time into time becomes time squared. So we have expressed the physical quantity acceleration in terms of displacement means length, and length is a fundamental physical quantity, and this is time square means time. Time is also a fundamental physical quantity. So all other physical quantities can be expressed only in terms of their length, mass and time. Suppose there is density, it is also a physical quantity, and the formula for density is defined as mass per unit volume. Mass upon volume. Again, mass is fundamental physical quantity, and volume can be expressed in length, breadth and height. Length, breadth, height. All these three are length, breadth is also length, height is also length. So density is a physical quantity which also can be expressed in terms of fundamental physical quantity, means in terms of length, mass and height. Now, what is meant by the term measurement? What is meant by the term measurement? Measurement of any physical quantities. Measurement of any physical quantities consists of two parts: unit part and numeric part. Measurement of any physical quantity always consists two parts: unit part and numeric part. Suppose you have to measure the length of this blackboard. So you will tell the length of this blackboard is either 5 meter, 6 meter. Here 5 and 6 is the numeric part, whereas meter is the unit part. The length, the unit of length is meter. So the measurement of physical quantity length consists of both parts, unit part and numeric part. Suppose you have to measure the speed, so you will tell the speed of motorcycle is 45 kilometers per hour. Here 45 is the numeric part, whereas kilometer per hour is the unit part. Kilometer per hour. This is the unit of speed. So always measurement of any physical quantities always consists two parts, unit parts and numeric parts. Measurement of any physical quantity always consists two parts, unit parts and numeric parts. Now we will see about the system of units. System of units. In the very beginning, the system was used was FPS system. FPS system. F means foot, A means pound, and S second. That time the length was measured in terms of foot, mass was measured in terms of pound, and time was measured in terms of second. Then another system came, and that was the CGS system of unit. In CGS system of unit, the unit of length, was centimeter. The unit of length is centimeter. C for centimeter. Centimeter. The length is measured in terms of centimeter. Mass is measured in terms of gram. And S second, time was measured in terms of second. Length was measured in terms of centimeter. Mass was measured in terms of gram, and time measured in terms of second. So that was the CGS system. Then another system came, and that system is called MKS system of unit. MKS system. M for meter, A for kilogram, and S for second. The unit of length is meter. The unit of mass is kilogram, and the unit of time is second. Now another system came, which is used all over the world. The system which is used all over the world is called SI system of unit. SI system of unit. International system of unit. SI system means that is international system. International system of unit, which is used all over the world. So the question arises that whether there is difference between MKS system of unit and SI system of unit. Are they same or is there any difference between them? So SI system is nothing new, but it is the simplest form of MKS system of unit. SI system is nothing new. Nothing new. It is the simplest form. It is the simplest form of MKS system of unit. Simplest form of MKS system of unit. How it is nothing new and how it is similar to MKS system, or it is the simplest form of MKS system? Let us see. There is a physical quantity called force, and the formula for force is defined as the product of mass and acceleration. Force equals to mass into acceleration. Now, what is the unit of force in MKS system and what is the unit of force in SI system? So, mass into acceleration. Acceleration equals to velocity upon time. Velocity upon time. Again, mass into velocity can be written as displacement upon time. Displacement upon time. And there is time also. So it becomes displacement upon time square. Now we have to write the unit of force in MKS system of unit. So in MKS system of unit, the unit of mass is kilogram, kg. The unit of displacement is meter, and the unit of time is second square. It becomes per second square. Kg meter per second square. You can write in this way also, kg meter per second square. So in MKS system of unit, the unit of force is kg meter per second square. But what is the SI unit of force? So in SI system, the unit of force is called Newton. Newton was scientist who discovered about the force. So in SI system, the unit of force is Newton. Simply it is written as N. The unit of force is Newton, N. In SI system, the unit of force. It means 1 Newton is equivalent. 1 Newton is equivalent to 1 kg into meter upon second square. So SI system is nothing new. It is the simplest form of MKS system of unit. Suppose the standard name 1 kg meter per second square called it Newton. So in SI system the unit of force is Newton, whereas in MK system the unit of force is kg meter per second square. Let us see another example. There is a physical quantity called work. Work equals to force into displacement. So what is the unit of work in MK system and in SI system? Now the formula for force equals to mass into acceleration and into displacement. Now write the unit of mass is kg, the unit of acceleration is meter upon second square, the unit of displacement is again meter. So it becomes kg meter square per second square. Kg meter square per second square, also written as kg meter square per second square. This is the unit of force in MKS system. Then what is the unit of force? Unit of work. This is the unit of work in MKS system of unit. Then what is the unit of work in SI system? So in SI system, the unit of work is given by given as Joule. Joule was also scientist who discovered about work. So Joule, 1 Joule is equals to 1 kg meter square per second square. So Joule is the simplest form of kg meter square per second square. So Joule is the SI unit of work, whereas kg meter per second square is the MKS unit of work. Thus, the SI system is nothing new, but it is the simplest form of MKS system of unit. Now we will talk about the dimensions and units of some physical quantities. We will talk about, here we will write physical quantity. Physical quantities their dimensions and their unit. What is dimension? To write the physical quantity in terms of M and T in a bracket. In a bracket like this, M means mass, L means length, T means time. To write the physical quantity in terms of MLT in a bracket is called dimension. This is the dimension, MLT. This is the way to express the dimension. Dimension is expressed, dimension of any physical quantities can be expressed in terms of MLT, mass, length and time, in terms of fundamental physical quantities. So, first physical quantities, we will talk about area. The formula for area, generally area is expressed in terms of length into breadth. Length into breadth. Where length is represented by L, breadth is also represented by L, so its dimensions becomes in area, there is no any role of mass and time. So it will be written like m naught, m raised to the power 0, m naught, and this is expressed by L, this is also expressed by L, L into L, L square. So m naught, L square. There is no any role of time, so t raised to the power 0. These are the dimensions of area. Now what is the unit of area? So the unit of, in MKS system, the unit of length is meter, the unit of breadth is meter, and meter into meter, that is meter square. The unit of area is meter square in MKS system. Next physical quantity, volume. Volume is expressed in terms of three lengths: length, breadth and height. Generally it is expressed in length, breadth and height. L into B into H. This is length, this is also length, this is also length. So its dimension becomes m naught. There is no any role of mass in volume. So m naught, L cube, L raised to the power 3 and T raised to the power 0. Its unit in MKS system is represented by meter, meter, meter. Hence meter cube. So the dimensions of volume is m naught, L cube, T naught. Now first physical quantity, density. Density is defined as mass per unit volume. Density equals to mass upon volume. Now we have to write its dimensions. So there is mass means m and volume. Upon volume is expressed as L cube. So in density there is no any role of time, t. So mass m, L raised to the power 3 can be written as L raised to the power minus 3. It will go to numerator place, becomes power becomes negative, and T raised to the power 0. Now about density, the unit of density, the unit of mass is kg, and the unit of volume is meter cube. The unit of density becomes kg per meter cube. The unit of density is kg per meter cube. Or speed or velocity both have the same dimension and have the same unit. The formula is distance or displacement upon time. So there is no any role of mass in finding the speed or velocity. Its dimensions becomes m naught, L and P raised to the power minus. And its unit, the unit of distance is meter and the unit of time is second. So its unit becomes meter per second. Next physical quantity is acceleration. Acceleration is defined as rate of change of velocity. Change in velocity upon time taken. Simply we can write velocity upon time. Again velocity equals to distance upon time. So it becomes distance upon time square. And its dimensions, there is no any role of mass in acceleration also. So m naught, L and T raised to the power minus 2. About its unit, the unit of distance is meter and the unit of time is square. So meter per second square. The unit of acceleration is meter per second square. Now we will talk about momentum. physical quantity and momentum is defined as the product of mass and velocity. Physical quantity, momentum, this is equals to product of mass and velocity. Mass into velocity. Its dimension, so mass m and velocity. Previously we have seen the dimension of velocity, distance, displacement upon time, L p की power minus 1. Its unit, the unit of mass is kg, the unit of velocity is meter per second. So the unit of momentum becomes kg meter per second. Next, force is defined as product of mass and acceleration. Its dimension, mass m. Previously we have seen the dimension of acceleration. Acceleration is equals to distance upon time square, means distance L upon time square, means p raised to the power minus 2. About its unit, in MKS system, its unit is the unit of mass is kg, acceleration is meter per second square, kg meter per second square in MKS system, and in SI system its unit is Newton. Now about work. Work is equals to product of force and displacement. Force into displacement. And about force, the force is given as mL t raised to the power minus 2, and again there is displacement. Displacement means L, and already there was L into L square. So m L square t raised to the power minus 2. Its unit, the unit of force is kg meter per second square. Kg meter per second square. And the unit of displacement is meter. So meter into meter, it becomes meter square. So kg meter square per second square. And in SI system, the unit of work is joule, simply given by J. The unit of work is joule. Next, energy. Energy, which is equals to amount of work done. And the same dimension, which the work mL squared t raised to the power minus 2, and it has same unit, joule. Next, we will see about power. Power equals to work done upon time. Work upon time. So work, the dimension for work was mL square t raised to the power minus 2, and that is time, t to the power 1. So we write it this way, mL square t raised to the power minus 1 and t raised to the power 1. So it becomes t raised to the power minus 3. And the unit, SI unit of power is watt. The SI unit of power is watt. Now we will talk about another physical quantity, that is pressure. Pressure is a physical quantity and it is defined as force acting per unit area. Force upon area. The dimension of force. Previously we have seen the dimension of force is mL t raised to the power minus 2. mL t raised to the power minus 2. And the dimension of area is L square. So 1 times L gets cancelled and it becomes m L raised to the power minus 1 and t raised to the power minus 2. m L raised to the power minus 1 and t raised to the power minus 2. In SI system, its unit is Pascal. In SI system, the unit of pressure is Pascal. Now, moment of force or torque. Moment of force or torque. Torque is the turning effect. The moment of force or torque is defined as force into perpendicular distance. Force into perpendicular distance. Now the dimension of force m L t raised to the power minus 2. m L t raised to the power minus 2, and that is distance L. Becomes m L square t raised to the power minus 2. m L square t raised to the power minus 2. Now its unit, the unit of force is Newton and the unit of distance, perpendicular distance, is meter. So this is about moment of force. Now that is gravitational constant. Gravitational constant. Gravitational constant is represented by capital G. We know Newton's law of gravitation. So according to Newton's law of gravitation, the force acting between two bodies having masses m1 and m2, the force acting between two bodies are directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. So that is gravitational force F equals to G m1 m2 upon r square. This is the formula for gravitational force. But we have to find the dimension of G, gravitational constant. So we eliminate G. So G will become F into R square upon M1 into M2. Now we have to write the dimensions of all these physical quantities. So the dimension of force is mL t की power minus 2, mL t raised to the power minus 2, r square. R is the distance and distance is expressed in terms of L. So L square, m1 mass, m2 mass. So m into m, it becomes m square. 1 times m gets cancelled and it becomes m raised to the power minus 1. L into L square, it becomes L cube, and t raised to the power minus 2. So the dimension of gravitational constant m raised to the power minus 1, L raised to the power 3, and t raised to the power minus 2. Now about its unit. So the unit of gravitational constant G. The unit of force in SI system given by Newton, R square means meter square, Newton meter square, and the unit of mass is kg, so per kg square. This is the unit of gravitational constant. Newton meter square per kg square. Newton meter square per kg square. Now we will see the next physical quantity, and that is called impulse. Impulse is defined as force acting for a very small interval of time. So impulse, force into time, force into time. The formula for impulse is force into time, force acting for a very short interval of time. The dimension of force is m e to the power minus 2, and the unit for dimension for time, this time is t. So m e to the power minus 2 into t, and combining these, it becomes m t raised to the power minus 2, and here t raised to the power 1, so it becomes t raised to the power minus 1. So m t raised to the power minus 1. This is the dimension of impulse, and about its unit. So the unit of force is Newton, and the unit of time is second. So the unit of impulse becomes Newton second. Newton second. Newton second. Now we talk about stress. Stress equals to force upon area. Force upon area. The dimension of force is m t raised to the power minus 2, area l square, 1 times l cancelled, and its dimension becomes m l raised to the power minus 1, t raised to the power minus 2. The unit of force is Newton. The unit of area is meter square. The unit of stress is Newton per meter square. Next is strain. Changing dimension upon original dimension. The formula for strain: change in dimension. Change in dimension upon original dimension. So both are represented in terms of L, both gets cancelled, therefore there is no dimension. Strain has no dimension, and also it has no unit. So this is about two physical quantities, its dimensions and their units.